In this video, we're going to talk about section 9.2, dealing with two means. Now, in 9.2, this section, we're going to be looking at two means that have independent samples. And in the next section, which is going to be the next video section, 9.3, we're going to be dealing with two means where the samples are going to be dependent. Okay. But for section 9.2, we're going to distinguish between a situation involving two independent samples and a situation involving two samples that are not dependent. Also, we'll conduct a formal hypothesis test of a claim made about two means from independent populations. Also, we'll construct a confidence interval estimate of the difference between two population means. Okay. Also, we'll discuss situations in which the standard deviations of the two populations are unknown and are not assumed to be equal. So that's basically what this section is. Now, it's important that you know the difference between independent samples and dependent samples. Here's the definition. Two samples are independent if the sample values from one population are not related to or somehow naturally paired or matched with sample values from the other population. And also, two samples are dependent if the samples are paired. That is, each pair of sample values consists of two measurements from the same subject, or each pair of sample values consists of matched pairs, where the matching is based on some inherent relationship. Okay, and the dependent samples we'll look at in section 9.3 or in the next video. Okay, so here is some notation. All right, for population 1, we have mu1 being the population mean. Sigma sub 1 is the population standard deviation. And then N1 is the size of the first sample. And then X1 bar is going to be the sample mean. And then S1 is the sample standard deviation. Now, for population 2, that's the corresponding notation for that. Mu sub 2, sigma sub 2, X sub 2 bar, S2, and N1. All right, the requirements of this. The population standard deviation of the first and the population standard deviation of the second are unknown, and it is not assumed that sigma 1 and sigma 2 are equal. And number 2, the two samples are independent. Number 3, both samples are simple random samples. And number 4, either or both of these conditions is satisfied. That is, the two samples are both large, where N1 is greater than 30 and N2 is greater than 30, or both samples come from populations having normal distributions. Okay. Now, this is the test statistic formula. When we're doing the hypothesis test for two means, that's going to be T is equal to the quantity of X bar minus X1 bar minus X2 bar minus the quantity of mu sub 1 minus mu sub 2. And that's all divided by the square root of S1 squared over N1 plus S2 squared over N2. Now here, mu sub 1 minus mu sub 2 is often assumed to be 0. And that usually comes from the null hypothesis, where mu1 is equal to mu2. And if that's the case, then those differences will have to be equal to 0. Degrees of freedom is this. We use a simple and conservative estimate, where the degrees of freedom will be the smaller of N1 minus 1 and N2 minus 1. Now, p-values, we can use table A-3, which is the t-distribution, or we can use technology. Mainly, we'll use the TI-84 plus calculator. Critical values can be referred from the t-distribution in table A-3. And now for the confidence interval. The confidence interval estimate for mu1 minus mu2, dealing with independent samples. The confidence interval estimate of the difference mu1 minus mu2 is going to be this. The quantity x1 bar minus x2 bar minus the margin of error, which is E. That's going to be less than mu sub 1 minus mu sub 2 and less than x1 bar minus x2 bar plus E. Now E is going to be the margin of error. To calculate the margin of error, we use this formula, T sub alpha over 2, which is your critical T value, multiplied by the square root of S1 squared over N plus S2 squared over N. And those S's represent the sample standard deviation, by the way. And the number of degrees of freedom is found by taking the smaller of N1 minus 1 and N2 minus 1. Okay, like I stated earlier, and here's another spoiler alert, we can use the graphing calculator, the TI-83 or 84 plus calculator, to come up with what we need, our confidence interval, and also when we do a hypothesis testing, we can get the test statistic for T and the corresponding p-value for it. You start by pressing the stat key, right arrow over to test. And then number 2, if you're doing a hypothesis test, you want to select two-sample t-test. That's two-sample t-test. And that's where sigma 1 and sigma 2 are not known. But if you're doing a confidence interval, you want to do two-sample t interval. That's two-sample t interval. And that's only for a confidence interval where sigma 1 and sigma 2 are not known as well. Then number 3, you want to select either data if your two sets of sample data are already stored in the calculator as list, or we select stats if we know the summary statistics. That's x bar, x1 bar, s1, n1, and then x2 bar, S2, and N2. Then number 4, if you select data in step number 3, you want to proceed to enter the list names or labels such as L1 and L2. And if you select stats in step number 3, you want to proceed to enter the values of the statistics for each sample. And then number 5, the next step depends upon whether you're conducting a hypothesis test or constructing a confidence interval. If you're doing a hypothesis test, you want to select the type of test, whether it's two-tailed, left-tailed, or right-tailed, and then select the format corresponding to the alternative hypothesis, because the alternative hypothesis will tell you what type of test you have. You're going to have to select either not equal to mu sub 2, or less than mu sub 2, or greater than mu sub 2. Now, if you're doing a confidence interval, you have to enter the confidence level. Okay, that's very important. And number 6, if using the t-distribution by selecting either two-sample t-test or two-sample t-interval in step 2, you will see a line displaying pooled, no or yes. Recommendation there, you select no, so the sample variances are not pooled. Then use the arrow key to scroll down to the bottom line, select calculate, and then press enter. Okay. Okay. Now here's just a flow chart that they provide here. Now we're only assuming that sigma 1 and sigma 2 are unknown. Okay. So if sigma 1 and sigma 2 are known, we just drop down to know we're assuming that that's going to be unknown. Okay. And then can it be assumed that sigma 1 is equal to sigma 2? And that answer would more than likely be no. So we use the approximate method. We approximate the method by using the t-distribution with the standard error, and this would be it. Okay. Also, confidence interval estimate of a population parameter contains the likely values of that parameter, and we should therefore reject the claim that the population parameter has a value that is not included in the confidence interval. So if that population parameter has a value and it's not in that confidence interval, we can reject the null hypothesis. Otherwise, fail to reject the null hypothesis. So here's the table again for the confidence level for a confidence interval, okay? But keep in mind, I did mention to you this. If you have a two-tailed test, that means your confidence level, which I'm abbreviating CL, is going to be 1 minus whatever your level of significance is, 1 minus alpha. But for a one-tailed test, whether it's left-tailed or right-tailed, to find the confidence level, you're going to do 1 minus 2 times alpha, or 2 times your level of significance, and you subtract 1 from it. Because in a one-tailed, because when you use table A-3, when you're doing the confidence level, you only use the area in 2 tails only and nothing else, okay? So if you recall table A-3, this is it. We only use the area in 2 tails when you're finding your critical t values. Okay, so now let's look at the first example, where we have this. Data on the weights in pounds of the contents of cans of diet soda versus the contents of cans of the regular version of the soda is summarized to the right. Assume that the 2 samples are independent samples or independent simple random samples selected from normally distributed populations, and do not assume that the population standard deviations are equal. Complete parts A and B below. Use a 0.05 significance level for both parts. In part A, we want to test the claim that the contents of cans of diet soda have weights with a mean that is less than the mean for the regular soda. And then part B is to construct a confidence interval appropriate for the hypothesis test in part A. Okay, so we're going to go through that 8-step procedure that we went through on previous videos. So I'm going to bring this up. This is that 8-step procedure for hypothesis testing, just to bring you up to speed. And you should already have that in previous notes. All right, part A. And step number 1 is to write the original claim in symbolic form. So that means here, let's see, the contents of diet soda, of cans in diet soda, have weights with a mean less than. So here, mu1 is the diet soda. And that's going to be less than the contents, the weights, the mean weight for regular soda, mu sub 2. And then step number 2 is the opposite of the original claim. Well, the opposite of less than will have to be greater than or equal to. So this will be mu sub 1 is greater than or equal to mu sub 2. And then step number 3 is writing our null an alternative hypothesis. All right, so the null hypothesis has the equal sign in it. So that means it would be mu sub 1 equal to mu sub 2, but that mu sub 1 is less than mu sub 2. That would have to be the alternative hypothesis, and it is the claim. So that goes here. Keep in mind, the alternative hypothesis always has either less than or greater than or not equal to. So this is mu sub 1 less than mu sub 2. And that is the claim. All right, step 4. State the level of significance in this problem. In this case, we have a 0.05 significance level. That will be the alpha level that we will be using here in this problem. Now, step number 5 is calculating the test statistic. Here we can use the TI-84 or TI-83 plus calculator to come up with our test statistic. So here I'm going to say from the TI-83 plus calculator. And this is a t-test, so we're going to get a t-test statistic. And I'm going to use that table that we have here. So here's my calculator. Let me clear this out. Now, in this case, to find that t-test statistic, we're going to press the stat key, go over to test. And now, under test, we want to select the menu item that says to samp t-test. And that's this menu item right here, to samp t-test, because we're dealing with 2 samples and we're conducting a t-test. And then press enter. Okay. Now, I just have the summary statistics here. So what I need to do here is use my right arrow key, put the cursor on stats and press enter, because I want to highlight the stats because I have summary statistics. I don't have the raw data values. I have the summary statistics as you see here. So stats needs to be highlighted under input. And then in X1, S1, and N1, we'll have the summary statistics for the diet. So X1, X bar 1 is this number 0.79641. So this will be 0.79641 and then enter. Oops. Enter. S sub X1, that's your standard deviation. That's this number right here, 0.00444. And then go to N1 after pressing enter. N1, that's going to be 30. And then X bar 2, X2, and N2 would be this column, which is for the regular COLA. So X bar 2, the mean for that would be 0.81614. And then go down to the standard deviation, X2. That will be that number, 0.00742. And then N2, that will be 30. Now, under mu sub 1, I have to select the correct inequality, either not equal to, less than, or greater than. I look at my alternative hypothesis and it says less than. Okay, so I put the cursor on top of the less than mu sub 2 and then hit enter to highlight that. Pooled is always going to be no. Don't worry about the color. We just go all the way down to calculate. Make sure that cursor is on top of calculate and then hit enter. Notice that it does give you the test statistic. Okay. All right, let me double check my numbers. .79. Oh, I made a mistake. It's 0.79841. I need to change that. Okay. This is where if you make a mistake, you're not going to get the right answer here. Then everything else is right. That's what I'm looking for. So here, that T is your test statistic, which is negative 11.23, if we round that off to 2 decimal places. So negative 11.23 is your test statistic. That's step 5. Now in step number 6, we can also use that graphing calculator to get the p-value. So I'm going to say here from the TI 83 plus calculator, the p-value is equal to, under the T is our P, and in this case, P is equal to 0. But let's say we want this to 3 decimal places. So here, the p-value is 0.000. So not only can you get the test statistic, you can also get the p-value from your TI 83 or 84 plus calculator. Let me change this to 84 because that's the one I'm using. But you can use the 83 as well. And now step number 7 is our decision rule, which is this: if your p-value is less than or equal to alpha, let me make that alpha look better. If your p-value is less than or equal to alpha, you want to reject the null hypothesis. So in this case, if that p-value was 0.000, my alpha level in this case is 0.05. And if I compare those two, I see that 0.000 is less than 0.05, less than. That satisfies the decision rules, and that means I need to reject the null hypothesis. Reject the null hypothesis. And then step number 8 is writing my conclusion statement using simple non-technical terms. Now, I rejected the null hypothesis and the claim was the alternative. That means that there is sufficient evidence to support the claim. So my statement here would be that there is sufficient evidence to support the claim. That the cans of diet soda have mean weights that are less than the mean weights for regular soda. Okay. So that's part A, is conducting that hypothesis test. Okay, now part B is construct a confidence interval appropriate for the hypothesis test in part A. Okay, now let's think about this here. We have a one-tailed test. And I know that because if you look at your alternative hypothesis, you'll see that it's just strictly less than. So that means we have a one-tailed test, or to be specific, a left-tailed test, since that less than symbol points to the left. And our alpha level is 0.05. So that means, and I'm going to abbreviate confidence level, that will be equal to 1 minus 2 times alpha. Okay. So 1 minus 2 times 0.05. If you type all of that in the calculator, you'll get 0.9. I'll say 0.90, or as a percent, 90%. That means we have a 90% confidence level. Okay. So now I'm going to use the graphing calculator on this one as well to get my confidence interval. So using a TI 84 plus calculator, here we go. All right, in this case, let's clear this and then press the stat key, go over to test. And this time I'm going to select 2-samp T interval. 2-samp T interval. Then press enter. All right, so my stats are already in here. X1 is that 0.79841. S1 0.00444. N1 is 30, and then X bar 2, 0.81614. S2 is 0.00742, and N2 is 30. So my summary statistics are already there. I need to change the confidence level, which is 90%. So 90% as a decimal will be 0.90. Pooled, I must keep it at no. Use your down arrow key to go all the way down and calculate, and then press enter. So this right here represents my confidence interval. Okay. Now, if I was to write this out as to 3 decimal places for a confidence interval, it would be this. Negative 0.020 is less than, now the middle is going to be this, mu sub 1 minus mu sub 2, and less than negative 0.015. Okay, so that represents this confidence interval that you see on the top. And does that confidence interval supports our conclusion of the hypothesis testing? Well, notice we only got negative values here. 0 is not in between those two negative values. So in this case, we can say yes. And that's because the confidence interval contains only negative values. Okay. All right. Now let me show you how I did this using the formula that I showed you. Notice in step 5, I use that T is equal to the quantity x1 bar minus x2 bar minus the quantity mu1, mu sub 1 minus mu sub 2, all divided by the square root of s1 squared over n1 plus s2 squared over n2. I substituted those values here to get negative 11.23. But when I got to step 6, I had to use the TI 83 or 84 plus calculator to get my p-value to 3 decimal places. Okay, and then for the confidence interval, to find 90% confidence, the confidence level of 90%, I had to do this. Well, they're both 30, so I had to use 30 minus 1 to get 29 degrees of freedom. 1 minus the confidence level for alpha, 1 minus 0.90 would be 0.10. That would be in 2 tails. So I had to use table A-3 to get 1.699 as my critical T value. And to find the margin of error, I had to use this formula, as you can see. Substituted S1, S2, N1, and N2, and the critical T value in this formula to get 0.0027. And I used the format for the confidence interval for 2 means with independent samples. And I came up with the same thing. Okay. So my advice to you, just go ahead and use the graphing calculator on this, on these type of problems. All right, here's the next example. A study was done using a treatment group and a placebo group. The results are shown in the table. Assume that the 2 samples are independent simple random samples selected from normally distributed populations, and do not assume that the population standard deviations are equal. Complete parts A and B below. Use a 0.05 significance level for both parts. So in part A, we're going to test the claim that the 2 samples are from populations with the same mean. So in other words, these 2 have to be equal. That's the claim. All right, so starting with step number 1, we want to state the original claim in symbolic notation or symbolic form. All right, so populations with the same mean, that means that mu1 must be equal to mu2. So there you have it. That's step number 1. Step number 2 is the opposite of the original claim. That would be mu1 not equal to mu2. The opposite of equal to is not equal to. Now, step number 3 is writing our null and alternative hypothesis. So one of these will be the alternative, the other one has to be the null. Well, this one has not equal to, so this must be the alternative hypothesis. And of course, mu1 is equal to mu2, that's the null. Keep in mind the null always has to equal to. The alternative has either less than, greater than, or not equal to. All right, step number 4. Step 4 is our level of significance, stating that that's alpha is equal to 0.05. Now, step number 5 is just using our technology, which is our TI-84 calculator that I'll be using. So from the TI-84 plus calculator, we're going to calculate the t-value. or the t-test statistic. All right, so in this case here, let's clear this out, press the stack key, go over to test, go down to t-test. We have stats, summary statistics, so stats needs to be highlighted. And now X1 bar, that's going to come from this first column. X1 bar will be 2.36. S1 bar, S1, that's going to be 0.96. And N1 is 31. Now for X2 bar, for the placebo group, that's this column here. 2.68 is your mean for that group. 0.63 is the standard deviation, and your sample size there is 37. Now, let's look at our alternative hypothesis. It says not equal to. So we need to highlight not equal to. Put the cursor on not equal to mu2 and hit enter, because that needs to be highlighted. No for pooled, oops, sorry. Okay. Check to see if everything's in here. All right, no for pooled should be highlighted. And don't worry about color, highlight calculate using your down arrow key, and then press enter. All right, so this is your test statistic, which is in this case, negative 1.59, and that would be to 2 decimal places. Negative 1.59. Now, step number 6 is our p-value. So step 6, that's also going to come from the TI-84 calculator. So here the p-value is this. And we'll get around to 3 decimal places. That's p. That represents the p-value in this case. And that would be 0.118. Okay. So that's step number 6. All right, now step 7. Step number 7 is our decision rule, and that's going to be this. If our p-value is less than or equal to alpha, we want to reject the null hypothesis. Otherwise, fail to reject the null hypothesis. So here our p-value was 0.118. The alpha level there from step 4 is 0.05. And if we compare those two, 0.118 is greater than 0.05. So that means this violates our decision rule. So we need to fail to reject the null hypothesis. And by the way, I need to mention that this was a claim. The null hypothesis is the claim. And we failed to reject the null hypothesis. Failed to reject the null hypothesis, and the claim was the null hypothesis. So that means that there is not sufficient evidence to reject the claim. In other words, we can say that there is not sufficient evidence to warrant rejection of the claim that the two samples are from populations with the same mean. Move this up a bit. So that's our hypothesis test for this situation. All right, now part B is to construct a confidence interval suitable for testing the claim that the two samples are from populations with the same mean. All right, we do have a two-tailed test because of the not equal to in the alternative hypothesis. Our alpha level is 0.05. That means the confidence level will be 1 minus the alpha level itself because it's already a two-tailed test. When we're dealing with confidence levels, we always deal with two tails, the left and the right. The confidence level is always in the center of that normal curve. So 1 minus 0.05 would be 0.95, or as a percent, 95%. So here we're dealing with a 95% confidence level. Now let's find that confidence interval. Okay, I'm going to clear this out, go to stat, go over to test. This time it's going to be 2-samp T interval. That's this menu item right here, 2-samp T INT, short for interval. Select that. Notice that X1, S1, and N1 are already there. X2, S2, and N2 are also already there. The confidence level we need to change to 95%, or 0.95. For pooled, it's always going to be no. Go all the way down, using your down arrow key to calculate. Hit enter. And this will be your confidence interval at the very top. Negative 0.724 to 0.084. All right, so let's write this as negative 0.724. That will be less than mu1 minus mu2 in parentheses, and then less than 0.084. Okay. Now, this does support our conclusion statement back in step 8, because notice I have a negative and a positive confidence interval limit. That confidence interval contains 0. So that means we can fail to reject the null hypothesis from here. Okay. All right, let's look at example 3. And that's this. Researchers conduct a study to determine whether magnets are effective in treating back pain. The results are shown in the table for the treatment with magnets groups and the sham treatment or placebo group. The results are a measure of reduction in back pain. Assume that the two samples are independent, simple, random samples selected from normally distributed populations, and do not assume that the population standard deviations are equal. Complete parts A and B below. So in part A, we're going to use a 0.05 significance level to test the claim that those treated with magnets have a greater mean reduction pain than those given the sham treatment. And then part B is constructing a confidence interval suitable for testing the claim that those treated with magnets have a greater reduction in pain than those given a sham treatment. So here's our table with our summary statistics. So in part A, we're going to do the hypothesis test. So step number 1 is the original claim in symbolic form. Now we're still using mu, so it'll be mu1. Let's see, it says here, those treated with magnets had greater mean reduction pain than those with the sham treatment. So mu1 would be greater than mu2. mu1 is greater than mu2. And then step number 2 is the opposite of the original claim. That's going to be, well, the opposite of greater than will be less than or equal to. So it'll be mu is less than or equal to mu2. This should be mu sub 1. Mu sub 1 less than or equal to mu sub 2. All right, step 3 is the null and alternative hypotheses. Let's see which one has strictly less than or greater than or not equal to. Has to be this one, the original claim. Mu sub 1 is greater than mu sub 2. That is your claim. The null always has the equal to. Mu sub 1 equals mu sub 2. And then step 4 is your level of significance. In this case, we're using a 0.05 significance level. So alpha is equal to 0.05. And then step number 5 is where we use the TI-84 plus calculator. To get my test statistic for T and the critical and the p-value for that. Clear this out, go to stat, go over to test. I'm going to select this one for 2SAM t-test. That's what I'm conducting. Stat should be highlighted. So first column will be X1, S1, and N1. Well, here's X bar 1, by the way. That's 0.53. And hit enter. S1, that's standard deviation, 0.59. And N1 is 27. And this represents the second column, X bar 2, S and S2 and N2. X bar for that would be 0.37. And then S2, 1.14. And N2, the sample size 27 as well. All right, let's look at our alternative hypothesis. It says strictly greater than. So that cursor needs to be on top of greater than mu sub 2, and I need to select enter to highlight it. For pooled, always no. Go all the way down and calculate, and then press enter. So this is your t-test statistic, as you can see. It's going to be 0.65. All right. And now step number 6 is our p-value coming from the TI-84 plus calculator as well. So p-value is equal to, going back to this calculator, under the t is your p-value. to 3 decimal place, that would be 0.260. Okay. All right, step number 7 is this. If the p-value is less than or equal to alpha, that's our decision rule, we're going to reject the null hypothesis. So now our p-value is 0.260. And then the alpha level from step 4 is 0.05. Compare those two, you'll see that 0.260 is greater than 0.265. That's violates our decision rule, so we need to fail to reject the null hypothesis. Okay, so here we failed to reject the null hypothesis, and our claim was the alternative. That means that there's not going to be sufficient evidence to support the claim. So here in step number 8, we say that there is not sufficient evidence to support the claim. That subjects treated with magnets have a greater mean reduction pain than those given a sham treatment. Okay, so that's the 8-step procedure for that. Part B is constructing a confidence interval suitable for testing the claim that those treated with magnets have a greater mean reduction in pain than those given the sham treatment. All right, in this case here, greater than means a one-tailed test, or more specifically, a right-tailed test. But anyway, it is a one-tailed test. And our alpha level is 0.05. That means our confidence level will be 1 minus 2 times alpha, or 1 minus 2 times 0.05, which will give us 0.90, or as a percent, 90%. So we're dealing with a 90% confidence level. All right, so let me go ahead and write this out by saying using a TI, using a T, using a TI 83, let's say 84. So I'm making all these mistakes here, but for using a TI 84 plus calculator, let's find that confidence interval. Clear this out, press the stat key, go over to test, and use your down arrow key to go to 2SAMP T interval, or 2SAMP T int, int. All right, the summary statistics are already there, as you can see. So now my confidence level, I need to change that to 90%. So this will be 0.90. Pooled is still going to be no. I'm going to use my down arrow key to go down and calculate, hit enter, and that will be my confidence interval. Let's say the 3 decimal places, it will be, I'm going to move this over, negative 0.256. That's less than, in parentheses, mu1 minus mu2, less than 0.576. Now I'm rounding this off, each of those limits to 3 decimal places. That 2 makes it 6, still be a 6. And as you can see here, the confidence interval does contain 0. That would mean that I will have to fail to reject the null hypothesis and conclude that there's not sufficient evidence to support the claim that subjects treated with magnets have a greater mean reduction pain than those given a sham treatment. Okay. All right, take a look at example 4. Here we go. Given in the table are the BMI statistics for random samples of men and women. Assume that the 2 samples are independent, simple random samples selected from normally distributed populations, and do not assume that the population standard deviations are equal. Complete parts A and B below. Use a 0.01 significance level for both parts. Some part A1 tests a claim that male and females have the same mean body mass index, or BMI. All right, so step number 1 is the original claim in symbolic form. So here, males and females have the same body mass index. That means that mu1 must be equal to mu2. So mu sub 1 equals mu sub 2 is our original claim. Step number 2, the opposite of the original claim. Well, the opposite of equal to is not equal to. So mu1 does not equal mu2. And then step number 3 is this, writing our null and alternative hypotheses. Well, one of them will be the null, the other one has to be the alternative. Well, the original claim has the equal to, so that will be your null hypothesis, because the null always has the equal to in it. So this is the claim. This time your claim is the null hypothesis. The mu sub 1 not equal to mu sub 2, that will have to be the alternative. The alternative hypothesis always has either not equal to, greater than, or less than. And then step number 4 is your level of significance. In this case, we're using a 0.01 significance level. Then step number 5 is calculating the test statistic using our TI-84 plus calculator. So here, we're looking for the t-test statistic with this calculator. Clear this out, press the stat key, go over to test, and we're doing a 2-samp t-test. 2-samp t-test. We have this stats already, the summary statistics here. So my X1 will come, X1, S1, and N1 would be in this column. Your X bar 1 X bar 1 would be 27.0625. Its standard deviation is 8.874512. Then go down to N1. That's the sample size for the males, that's 49. And then the second one, X2, X bar 2, S2, and N2 would be for females. X bar, that's 26.5325. S is 4.165223, and your N 49. Now let's look at our alternative hypothesis. It says not equal to, so that means we need to highlight the not equal to mu sub 2. Pooled will still be no. Go all the way down to calculate and press enter. All right, so now you see what your test statistic is going to be. Now the 2 decimal places, this will be 0.38. And now step number 6 is the p-value. We can also get that from the TI-84 plus calculator as well. So under the T is your p-value right here. Let's see, the 3 decimal places, that's going to be 0.706. 0.706. And now step number 7 is our decision rule, whether to reject the null or fail to reject the null. If the p-value is less than or equal to alpha, you want to reject the null hypothesis. Now your p-value is 0.706. And the alpha level is 0.01. Well, you can see that 0.706 is greater than 0.01. So that means in that problem, we need to fail to reject the null hypothesis. So now our decision rule is this. The claim is the null hypothesis, but we fail to reject the null hypothesis. So that means that there will not be sufficient evidence to reject the claim. Okay, so our statement is there is not sufficient evidence to warrant rejection of the claim that males and females have the same mean body mass index. Okay. Okay, so that's part A. And now part B is to construct a confidence interval suitable for testing claim that males and females have the same body mass index or the same BMI. Okay. If you look at the alternative hypothesis in step 3, you see not equal to. That means we have a two-tailed test. Two-tailed test. The alpha level there is 0.01. That would mean our that means our confidence level will be 1 minus alpha because it's already a two-tailed test. So 1 minus 0.01 will end up being 0.99, or as a percent, 99%. So our confidence level for this situation is 99%. And again, we can use our calculator to come up with the confidence interval for that. All right, so go to stat, go over to test, go down to 2-samp t interval, 2-samp t interval. Press enter. Notice that the summary statistics for this is already there. We just need to change the confidence level to 99% or 0.99. Pool should be highlighted with no. Go all the way down to calculate, hit enter, and there's your confidence interval at the top. So I'm going to write this out as, well, let me write this as using ATI 84 plus calculator negative 3.101. That's less than mu1 minus mu2 and less than 4.241. And notice my limits are rounded to 3 decimal places in this case. Okay. And does this support my conclusion that I got in part A? Of course it does. And the reason for that is because the confidence interval contains 0. Okay. So if the confidence interval contains 0, that means we automatically fail to reject the null hypothesis. And we can make that conclusion that we made back in part A in step number 8. Okay, here's one last example in this video. This is a little bit different because now you're given the raw data. Listed in the data table are amounts of strontium-90 in a simple random sample of baby teeth obtained from residents in 2 cities. Assume that the 2 samples are independent, simple random samples selected from normally distributed populations. Do not assume that the population standard deviations are equal. Use a 0.01 significance level to test the claim that the mean amount of strontium-90 from city number 1 residents is greater than the mean amounts from city number 2 residents. Okay, so now this one's a little bit different because we're not given the summary statistics, we are given the raw data. When that happens, we need to enter this raw data in our calculator, and I'm going to show you how to do that. So let me clear my screen out, press stat. Now we're going to be entering raw data in 2 columns. So from this menu under edit, I'm going to select number 1 for edit. Now notice I got a lot of crap in here, so I need to clear this out. So to do that, you want to use your up arrow key to highlight L1 in this case, press clear, and then enter. That clears everything out. I'm going to do the same thing for L2. Up arrow, hit clear, then enter. For here, up arrow to highlight L3 in this case, press clear, and then enter. Same thing for L4. Up arrow to highlight L4, press clear, enter. Now, here's what I'm going to do. For city 1, those data values will go into L1. And then for city number 2, those data values will go into L2. So now, in L1, we're going to enter this column in for city 1. So let's start off with 100. Now you press enter after each entry. So 100, then enter. 86, hit enter. 121, 111, 101, 104, 213, 124, 290, 124. This should be 290. And then 100, 250, then finally 145. Even though 145 is the last number in that column, you have to press enter no matter what. Okay. So everything should be correct. And do make sure that your data values that you enter are correct. Then use your right arrow key to go up to L2 and then enter those data values here in this for that column in L2. 117, 63, 100, 85, 86, 107, 110, 111, 148, 133, 101, 209. Okay. Now always double check to see if those data values are correct, because once you get your test statistic and your p-value, if they're incorrect, that means that somewhere you messed up. You put in the wrong data set, the wrong values. Okay. Now, let's start our 8-step hypothesis testing procedure. Okay, and I will come back to this shortly and show you how to do this. All right, step number 1. We're going to write the original claim in symbolic form. And we're still dealing with mu's here, mu1 and mu2. And here I'm going to let mu1 equal city number 1. And mu2 is going to be city number 2. And the claim was that the mean amount of strontium-90 from city number 1 residence is greater than the mean amount from city number 2 residence. So that will mean that mu sub 1 must be greater than, that's the symbol, mu2. That's the original claim in symbolic form. Now, step number 2 is the opposite of the original claim. That's going to be mu sub 1. The opposite of greater than would be less than or equal to mu sub 2. And then step number 3 is writing our null and alternative hypotheses. Well, that mu sub 1 is greater than mu sub 2, that has to be the alternative hypothesis. And that's going to be the claim, by the way. Your null has the equal sign in it, so mu1 is equal to mu sub 2. And then step number 4 is the level of significance. And that problem does say use a 0.01 significance level. And here's how we're going to calculate the test statistic from this raw data. So I'm going to pull the calculator back up here. And let's see. The way we're going to have to do that is this. I'm going to go to stat, press the stat key, go over to test. I'm still going to be using a 2-sample T test. So I'm selecting that menu item there, 2-sample T test. Now, this time I don't have the summary statistics. For the input, I'm using the raw data. So I need to use my left arrow key to highlight the word data and press enter. Now, what it's going to do here is give me this list 1, which is either going to be L1 or L2, and then list 2 will be either L1 or L2. Notice it defaults for list 1, the default is L1. For list 2, the default there is L2. Now, if you don't see L1 for list 1, what you're going to need to do here is this. There's a second key, which is this blue key, and then number 1. You press second and number 1, because right above the number 1 key is L1. And then for list 2, if it's not L2, then you must press second and number 2 for L2. Now the frequency 1, frequency 2, do not worry about that, but worry about mu1 being not equal to or less than or greater than mu2. Take a look at your alternative hypothesis. It says greater than, so the cursor needs to be on top of greater than mu sub 2 and hit enter to highlight it. Pooled remains no. Don't worry about the color and go to calculate. Highlight that, put the cursor on top of it, but you're going to press enter. And take a look. You do have your test statistic given to you. And the p-value. So in step number 5, I'll just say this. From the TI 84 plus calculator, your T to 2 decimal places, this will be 1.41. That's your test statistic. And step number 6 is the p-value, also from the TI 84 plus calculator. I'll just say here p-value, and we're going to round this up to 3 decimal places. This will be 0.089. Okay, that's the p-value. And now step number 7 is our decision rule. And that is if the p-value is less than or equal to alpha, you want to reject the null hypothesis. So here the p-value was 0.089 and our alpha level was 0.01. If you compare those two, you'll see that 0.089 is greater than 0.01. Does not satisfy the decision rule, so that means I need to fail to reject the null hypothesis. And then step number 8 is the conclusion. Well, the claim was the alternative hypothesis. I failed to reject that null hypothesis. That means that there is not sufficient evidence to support the claim. So my conclusion statement for this situation is that there is not sufficient evidence to support the claim. That the mean amount of strontium 90 from city number 1 residents is greater than the mean amount from city number 2 residents. Okay. And that's all they asked for in that problem there. They didn't ask for the confidence interval, but if we were to do the confidence interval, pretty much you'll get a confidence interval where the lower limit is negative and the upper limit will be positive in that interval. And 0 will be in that interval. So that conclusion would be the same. Okay, so that will conclude this video on section 9.2, dealing with two means with independent samples during the hypothesis test and the confidence interval. Hopefully this will assist you in completing the homework for this section, and do feel free to email me if you have any questions about what was presented in this video and in the homework.